So hi, I'm Ryan. This is a presentation on some work that I did with the Air Force. It was sponsored by the Air Force, and I did it with my coworkers, Ben Nargi and Patrick Cummings. And I guess to give you a little bit more about myself, at Aptima, I'm the lead for interactive intelligent systems, which means that I think a lot about human-machine teaming as a concept. That can mean a lot of different things, and some of you are probably already familiar with it. In fact, Anthony is using some of the methods that are key behind that right now, and deep learning is a whole situation that I can go into diatribes on that for a while. But kind of the big areas that we look at are military use. We can look at assistive tools and kind of training and workplace automation, and then kind of the same thing in the medical field, although there's different regulations. Anyone who's ever dealt with HIPAA understands the difference there. This work was sponsored by the Air Force, so I'm going to talk about that, and I'm specifically looking at the Air Force intelligence analysis domain, which is kind of the first time I've ever been allowed to say that out loud. Cool. What I'm interested in actually, so the common theme among all of these things is that machines fundamentally are actually quite dumb. Your computer doesn't know anything. It just knows how to do stuff because we told it that that's what you do with this little electron and some piece of quartz, and it's how it works. And what we're trying to do is figure out ways to make them less dumb. There's a lot of geospatial analytics out there that we use all the time. I mean, the one that I'm actually intersecting with most here is one that's going to be all familiar to you, is route navigation. And the thing about that we're trying to where we're going with this is, how do we mine cartographic interactions to infer human cognition? Because we're doing the thinky bits, and the machine is just kind of putting out some stuff on the end. There's kind of this spectrum where you go through some interaction mining, you do some context-aware computing about that, and then you end up with either an adaptive or an intelligent interface, which by necessity kind of defines an adaptive or intelligent experience. And what you can do with that is basically along a spectrum of two things. At one end, there's automation, which is the traditional, how we've been thinking about it for the last, 50 years, where you get a machine that replaces some well-defined, really well-specified, and narrowly scoped function in society. And actually, going back to the previous slide, you have the function of an auto worker lifting up a car door to attach it to a thing. You can actually fully automate. Ask Tesla about how you can fully automate automobile production lines. The more interesting thing, and the thing that's actually really quite hard, is the augmentation piece, where you develop some new workflow out of these cool interactions between the human and the machine. And that's something that DARPA is currently funded, and if you're interested in doing that, please talk to me, because right now it's getting $30 million worth of research funding, so lots of opportunities there. I'm going to be looking at a specific class of what I consider kind of more automation-focused analytics that are called pattern of life analytics. They're really about taking heterogeneous data sets and pulling out the discrete little patterns and the repeatable things that we see time and time again. Pattern of life in and of itself doesn't really do anything. It just kind of gives you a baseline of data that you can use for other tasks, like pathway analysis, which is how we get to and from roadways. That pattern of life analysis is fundamentally how your traffic data works in your mobile phone. You can also do more interesting things about activity-based intelligence and other things like planning, but those become slightly more complicated topics. The way that you teach these is actually, at least, there's many different ways that you could teach an algorithm. The way that we're focusing on is semi-supervised learning, so that's at least how I'm framing it, as unintentional learning, where the user is just doing a thing, and we're kind of mining their interactions to teach them, to teach the machine later. The user doesn't actually know that they're teaching any, or they're doing any of that stuff. So in terms of scenario and use case, not to be a total downer, but this is stuff that's relevant to the military. One time the Russians shot down MH17, and so we've been using that for the last few years, because there's a whole body of open source literature that we don't have to worry about classification issues on, and we can just talk about it. What intelligence analysts were asked to do following the downing of MH17 was essentially put together a storyboard. What happened? What were the key events? Where did it stop? Where did it start? How did this, what the hell happened? And what that kind of, it is basically a storyboard, but it's also a storyboard that happens in a map. So there's this linear temporal context of playing through a movie, but there's also the fact that one of the best quotes I ever got was from a colonel in the Army who said, any soldier or airman thinks in maps. We don't, if you can't convey the story on a map, we don't really, it's not going to stick to us for some reason. And that's probably says a lot about the history of cartography and map use generally. But so what we tried to do was create this prototype and then evaluate it, and that's really what I'm talking about here. So it's a map-centric tool. Please ignore the geography. This is the Ukraine, and if you look at the time stamps on the timeline at the bottom, there's like 25 minutes where somebody went approximately 250 kilometers, which would be an amazing speed record. So let's just ignore the geography of this and say that this prototype that was made in Sketch and Flinto is really about testing out ideas and not about actually making like really accurate stories themselves. So in the center of this whole thing is a map, and you can see it's just a web Mercator. This is throwing this together very quickly. Below the map is a timeline, and the idea is that you actually create events where you have a start, which is the green, and an end, which is the red, and then you have events in between, which are those little purple dots, and then we kind of coalesce them in both geographic and spatial contexts. And our research questions are really wordy, because this is how I have to present my slides to my customers. But basically, I'm asking two questions. What are the sticky interactions? And sticky interactions are anything that you would actually like willfully do on your own. It's not like extra cognitive work to get you to do this thing. And then what are the rich interactions? And that's basically defining how much can we learn from that. And because there's a lot of things that you do that we can't learn from, because a lot of the cool stuff that you would learn is happening between here and here. And then there's a lot of things that you won't do, but we could learn a lot from because they're just kind of tedious. And that's why we created Amazon Mechanical Turk, quite literally. The second question in this is and that's actually where we spent most of the money for this project, how do we translate those interactions back into something the machine can learn from? That is a non-trivial problem, and one that we're hoping to explore in the future. So. The way that we studied this was this was sort of a design that was forced upon us, and you kind of make the best of it. We have these twice a year. We get access to actual operational users, and we generally split it up. So this year we had 12. They were split up into 4 focus groups. Each focus group lasted for about 45 minutes. And we use these 3 methods: cognitive walkthrough, which is an actual usability assessment method from human factors community; hybrid cognitive task analysis, which is really a design method, but it's a way that we can kind of blend together the design and the evaluation components of this, so we can go kind of deep on specific features that they would need or want or think are cool. And then at the end, we use the system usability scale just as a survey method, just to see kind of a general heuristic. We had a size of 12, and military people, God love them, are all very positive. So we didn't actually get that much useful information out of the system usability scale, so I actually won't be talking about any of the results from that. Participants themselves, like I said, we have 12 of them. They're enlisted and officers, but we had a mix of both, and their responsibilities as a result of that are quite different. Enlisted people tend to be the ones on the floor who actually do the analytical work. They're the ones pulling out looking at the imagery, annotating the thing, and saying yes or no on is target identified. Officers are the ones who are doing things like quality assurance and team management and lots of communications, making sure PT is happening. And so it's kind of just a different modality there. We also had a weird split between unit intelligence and what I consider operational and strategic intelligence. Unit intelligence is really looking at we have a signal that's in our area of operations that basically means a surface-to-air missiles in the area, and we're about to fly F-22s through there. This is bad news bears, we need to move. Whereas operational and strategic intelligence are more looking at the problems like we are with MH17, and they're saying, oh, this is how this happened, and this is what this means, and if we want to detect it next time, this is what we would look for, and if we want to do something with it now, here's what we could do. Lots of different data modality experiences here. There's big imagery, obviously. Signals intelligence, geospatial intelligence, which is a superset of imagery. Measurement and signatures, which if you're not familiar with that, it's basically tank counting, fancy tank counting. And then there's open source, which is looking for news feeds, social media, things like that. So that's our participant pool. And I'll just summarize the results quickly and say that we had basically 2 really sticky interactions came out of this, and then 1 that was really challenging. So the stickiest of them all, and actually the richest of them all, thankfully, was narrative construction. They really love making the storyboards. That is their favorite activity. It is the most engaging thing. It puts them in the most different headspaces. It's really cool. The other thing is linked filtering. It's You've probably all seen this before. I mean, everybody who's done visual analytics work has seen this, where if you search for one thing and then click a filter, you see its impacts elsewhere. So they love that. The challenging interaction is anything that would count as a validation exercise. That's assigning, like we were talking about earlier, credibility and reliability scores, which they score independently, and so should you, question mark. They also do things like scoring confidence, anything related to geocoding. That's all stuff that can sort of be summed up by the old meme, ain't nobody got time for that. That's actually literally what they want these machines to do. The problem is the machines aren't good at doing that. Yeah, at least not reliably. And the things that we didn't support, mostly because of a function that we didn't have the data at the time, and we wanted this to be at least somewhat realistic, was layering and looking across feature types. So specifically, and that's actually the really challenging bit, is how do you design an interaction within Flinto that looks at the interplay between points and lines and polygons and the human cognition around that, and like, what does that mean? That was just kind of slightly out of scope for the timeline that we had to do this. This whole project was done in 6 months or less, and none of us, it was not the full-time focus for any of us. So yeah. All right, so getting into the more kind of detailed things, the narrative creation, like I said, super sticky. What they like about it is it's really tangible. They're literally moving points, like they're searching for things, they're seeing them on the map, and then they're dragging them from the map down into the timeline, which creates and establishes that spatial and temporal context on the right. They like that it's directly manipulable. They like that it just stimulates them in every possible cognitive way. This is like the work that they really want to be doing. We can learn a lot from that because the thing that's actually interesting is the story and the narrative that it creates, and it really gives us an idea of like what are the cool meta characteristics of this data that define the spatial and temporal patterns that we're looking for and that might be useful in the future. The other one, linked filtering, kind of got into this before, but if you have let's see if I can do this in real time. Hey, look at that. So if you search over here and then you click one of these buttons, it's like, I only want to look at videos. We filter out anything that's not a video, which is this little guy, which you probably can't see in the back. And then if you click on one of them, we filter out the other video and show you just the one that we're interested in. And so they really like that because it gives them, it still retains spatial context in their display, and it makes them feel like they don't get lost. The things that we can learn from that are actually also quite rich. More meta assessment, more individual preferences, and that's looking at like Netflix and Hulu for those sorts of things, like what information is relevant and useful to this person doing this task. The difference here is that if any of you are doing information on relevance of geographic things, be careful with Netflix and Hulu-based recommendation engines. There is a very explicit warning in the beginning of most of them that they assume that human preferences don't change. This isn't true in this context. Human preferences change all the time. It's just we don't really change that much about our entertainment preferences. Like, I'm still going to like Led Zeppelin 20 years from now. It's just going to be a thing. Whereas my preferences for work really do change a lot. The challenging UX, like I said, is anything validation related. They just hate doing it. It takes up time. It's tedious. It requires a lot of precision. And they consider it fiddly, or for my Canadian friends, fussy, which is a word I learned from Scott Bell not too long ago. And hi, Scott. Hopefully you're watching this. And then it's also kind of inconsistent, and that's sort of a function of how confidence, reliability, and credibility are all described and defined in their operational context. It's off the cuff. Do I feel confident, and do I think this is a reliable source? How do we validate that over time? How do we validate that at scale? None of this works. This was all like fundamentally work that was done in 2008 by some people at Army TRADOC, and the scale's just populated. It's how it happens. So we could learn a lot about it. We could do the biggest thing that we could learn is probably belief function, and looking at how we could do crowd scale belief functions, like this is Mechanical Turk, but they really don't want to do it, so we have to figure out what to do about that. Anyway, to close up, we validated the proof of concept. They did like it. The next step there is really to get into the nitty-gritty of what the cartographic interactions actually are. Luckily, Rob Roth published like a 60-page paper on how to do exactly that. And the second thing is that we just don't have enough rich interactions yet. Looking specifically back at the layering thing, and then also how do you infer the thinky bits We would like to have, we're trying to buy some eye tracking capabilities, and then also looking at multimodal interaction. Can we capture speech? Can we capture, not necessarily gesture, but maybe chat messages, things like that, that talk about, that actually get into communication patterns of how people like work with each other. And then finally, like we need to find a way to make secondary spatial temporal analysis tasks sticky. There just needs to happen, or at least not so abhorrent that they won't do it. And I don't have a good answer to that one yet. So if anybody does, please let me know. And that is it, and I think I'm done on time. All right.